Conditional logic is a more modern type of logic, and it allows us to use expressions like if P then Q. But this is only one of the possible logical operators. We can use negation that we are going to see in this lecture, but many others like and, or, exclusive or, etc., etc. But we are not going to pay attention to those operators in this lecture. So let's start with this case. If P, then Q. So that's the first premise. Second premise, P is true. Then what can we say? What can we conclude with certainty? Okay? We need to see what a valid argument will let us conclude. And in order to do that, we use the mental models. So here I've got three P's that are aligned with three Q's. That means that whenever P occurs, or P is true, then Q will be true, or Q will occur. Now, as in the previous mental models, I added Q's that are not aligned to P. Why is that? Because I'm not saying that if Q occurs, then P must occur. So if Q occurs, it may be that P occurs or not. But if P occurs, then Q necessarily will follow by this premise. Okay, second premise, I'm saying P occurred. So we aligned P with anything possible, and when in all the possible P's, it will be aligned with the Q. So if P is true, then we can conclude that Q will be true as well. Now, this is a valid argument, but is it useful for scientists? Let's see an example in psychology. First premise, if the mind is in the brain, then activating the brain will produce a sensation. So, if the mind is in the brain is P, then activating the brain will produce a sensation is Q. Okay, so we got that premise. Then if we say P is true, so the mind is in the brain is true, then we necessarily conclude, using a valid argument, activating the brain will produce a sensation. Now, this is all well and good, but that's not what scientists do. Because instead of affirming again the theory, sorry, I will return to the previous slide. So in the second premise, the scientist is saying the mind is in the brain. But that's not what we do. We don't affirm again the theory that it's in the premise. What we try to do is to test whether the theory is true. So what we do is to go to the brain, activate it, and see whether the sensation was produced or not. Okay, so this valid argument is not useful for scientists, because yes, it produces a necessary conclusion, but we are just affirming the theory without doing any science. Okay, so let's try a different argument with P and Q. So if P then Q, now I said Q is true. Now, what valid argument what can I conclude following a valid argument? Actually, nothing. So we've got here, if P then Q occurred. So in this case, P occur as well. But we've got this counterexample in which Q occurs, or Q is true, and P is not. So, because it could be true or not, I cannot conclude anything. Okay, let's see the example. If the mind is in the brain, then activating the brain will produce a sensation. Then activating the brain produced the sensation. So Q occur. Q is true. But nothing follows. So that's That's the problem, because that's what scientists do. They go and activate the brain and see whether a sensation is produced. That was what the hypothesis of the first premise said, and we go and test it. But the problem is that we can test it as many times as we want. We find that the sensation occurred when we activated the brain every time, but that's not a valid argument. A valid argument doesn't allow us to say that the mind is actually in the brain. So that's the problem. Now let's try 2 more options to see whether we can use deductive logic in order to do science. Let's see this one. If P then Q, that's the same as before. Now we say not P, so P is not true. Well, this one doesn't help at all. First of all, not P is aligned with Q, and not P could be aligned with not Q as well. So it's a useless argument. But even if it was a valid argument, it's not helpful for scientists. Because let's see the example. If the mind is in the brain, then activating the brain will produce a sensation. Now we say the mind is not in the brain. It's like we are contradicting ourselves, and so that's not what we do in science. Anyway, the argument, we cannot conclude anything. So let's try the different one. If P, then Q, and then we negate Q. Can we have a conclusion that validly follows from the 2 premises? Actually, we can. We have not Q there, and we aligned with not P. Can we have a not Q that aligns with P? No, because all the Q's are aligned with P, and not Q's definitely will be aligned with not P's. So actually we can conclude not P. And that is what we can do, falsification. Now, let's see the example. If the mind is in the brain, then activating the brain will produce a sensation. So activating the brain did not produce a sensation, so we tested and we didn't find what we predicted. So we conclude the mind is not in the brain. Now, this is a valid argument. And this is actually what Karl Popper proposed as what science should do. Science should falsify hypotheses, attempt to falsify hypotheses. Now, we are left with a paradox. Let's say we obtain, we go and activate the brain and we see whether there is a sensation or not. Millions of times, we observe a sensation. But that doesn't confirm the theory that the mind is in the brain. We observe only one time that the activating the brain did not produce a sensation, and that refutes the theory that the mind is in the brain. This seems a bit harsh for the theory. 1 million times or millions of times the predictions were observed, and once wasn't, and the theory is refuted. Scientists were not happy with this, so that's why they explored the possibility of inductive.